unique elements or distinct elements. But then if you're using live data, it's not that complicated to also overcome this. So I would create a method that's called as distinct. And then here, I will just be working with a mediator like data, where I'm adding as a source the query in the DAO. So then I keep in memory the last object that was emitted. Initially was not. And then whenever something was emitted, so whenever on change is triggered, I'm just comparing if that new object is the same or not with the object I previously emitted. And that's it. Okay, so another difference between synchronous and asynchronous or observable queries is the threading model. So this means that both live data and flow will run on the background thread. So the query will be done on the background thread. But the difference comes in where the result is returned. Because live data will automatically return the result on the main thread, where the result is returned. Because live data will automatically return the result on the main thread. Whereas the flow will, well, it will return the result on whatever scheduler you're setting. The last query that we've added actually quite recently is the raw query. So this means that if you want to dynamically define your queries, you can work with a support SQLite query. So this is something that just comes from SQLite. And then you can annotate a method with raw query. And then under the hood, Room will take care of doing the object mapping for you. So it will take care of creating everything that's needed for the query and return the data that you're interested in. You can also return observable queries. But on top of the raw query, you have to add what are the observed entities that you're interested in. So in my case, it's just the record class. But if the query that I'm triggering is something that connects multiple tables, make sure that you're adding here all the tables that you need. Okay, database relations. So let's say that we have a record class and the corresponding table. And we also have a commit class with the corresponding table that keeps all the commits for all the records. So this means that there's a connection between the primary key and the repo, and then the field repo from the list of commits. So in order to enforce this connection, we would use foreign keys. So here we would say, what's the connection between the repo class and the commit class, and say that this is based on the ID, respectively repo ID columns. And then Room also allows setting what should happen on a delete or on update. So all of this, all the foreign keys concepts are not foreign to us because they just come from the SQLite database. Room just exposes APIs to work with them. But let's say that we want to get a repository with the list of commits. So in order to do this, you would usually need to first get all the repositories and then based on all of those repositories, get all the commits for them. So you would need to trigger 2 queries. So we know that this is not really, let's say, handy, so we can help you. We can help you with the relation annotation. So more precisely here, I'm defining that I'm telling Room I want all the fields from the repository, from that table. And then I'm adding a list of commits. And by doing this, I'm telling Room that I'm connecting the repo ID field from the commit. So automatically, Room will trigger both of these queries that we defined before. And then in the DAO, all we need to do is tell Room that we want a list of repo with commits. And then that's all. In order to test this is what we need to do. So we would work with the database, we would work with a DAO. We would need to implement an Android unit test for this also. So in the add before method, we will need to define an in-memory database. So the advantage of an in-memory database is that it doesn't keep the data after the process starts. So as soon as the test has finished, everything we've inserted or every work that we did with the database will be removed. And then to actually implement a test, we would insert some data, and then when we're working with live data, we would need to get the list of repositories, let's say by name. And one thing to remember is that you need to add the instant task executor rule. So because by default live data will work on the background thread, we want to make this a synchronous operation. So this instant task executor rule will replace the executor that architecture components is using under the hood with a synchronous one. So this means that afterwards you can easily get the value that was returned or that was emitted by the live data and check that indeed that is the requested one. Using the RxJava flowable, things are pretty similar. So you would still need to use the instant task executor and then just get the test value and then assert, get the test and then assert that the value is the one that you'd expect. But then, if you want to implement espresso test that under the hood also tests code that uses rule, that uses asynchronous operations, then you would use the counting task executor rule. I won't go over in detail of how to use this, but check out the samples that we have because we also have examples of how to use this counting task executor rule. I also wanted to talk to you today about migrations, but this is quite of a bigger topic. And because I also want to tell you about paging, I'm just going to point you to two articles that I wrote, one about understanding migrations in Root and one about testing migrations. I don't think they're easy to do. We also provide handy tests. I think it's hard to do because we're also providing some very handy test rules to test the migrations. So we talked about holding or keeping the data in the database. But the thing is that a lot of times our apps are working with large sets of data, but in the end, they only need to display small amounts of data at one time. And if we're not careful, we might end up requesting data that's not needed. And we know that it's actually quite difficult to present fresh data to the user, especially if that data ends up changing or being changed by a third party. And then it's also hard to keep small amounts of data in memory, so to avoid getting all that data from database, for example. So in order to help with this, we've created the paging library. So I want to go today over the main components of the paging library. And the example that we will use is also a list of repositories. So more precisely, we are just querying the GitHub API and getting all the repositories that have a certain name. So let's look a little bit at the architecture of our application. So we would have a repository that would work with a network and with a database. And then usually in our apps, we would expose live data of a list of repositories. Then we would have a view model that works with that live data of a list of repo. And then a UI that is in charge of displaying that list. So it will have a recycler view adapter and an actual recycler view. Okay, so one of the main components of paging is the page list. So page list is actually nothing more than a collection. It actually extends the list. But what it does is load data in pages asynchronously. So this means that in our application, instead of working with a live data of a list of repos, we would work with a live data of a paged list. And then let the paging library do the paging, the requesting of the data in chunks for us. But then the page list will be consumed by the page list adapter. So by default, when you're using the recycler view, chances are that you're either using recycler view adapter, or if you've already migrated to the 27.1 version of the support library, you might be using the list adapter. So the page list adapter is nothing more than a wrapper over list adapter, so it extends list adapter. So if you haven't worked with list adapter, I'm going to tell you what's with that wrapper comparator. So based on the repo comparator, we're telling the diffutil, so we're telling the recycler view how to compare two different items. We're telling based on what two items can be considered the same or can be considered the contents of these items are the same. So this means that we would work with a page list adapter, and then in our UI, we would just submit the list. So here we are observing the live data of a page list, and whenever on change is triggered, we are setting that list to the adapter. So then, in our UI, we're just changing the recycler view adapter to a page list adapter, working with a page list. Another element is the data source. So where are we actually getting the data? Its role, the role of this class is just to load snapshots of data into a page list. I'm not going to go right now in detail about this, but I will a bit later. We also need to define a data source factory, where we define how should the data source be created. So in our case, we just need to implement the create method and create the data source that we need. Okay, so looking at our diagram again, we see that we have a live data of a page list, we have a page list adapter, and also a data source factory that gets the data from a data source. The data source can either be the database or the network. But what we haven't done is actually construct that live data of a page list. And this is done with the live page list builder. So more precisely here, you would pass as a parameter in the constructor the data source factory and the page size, or more detailed information of how you want to configure your page list. So this is what you can configure. You can set the size of the page. What we recommend here is to make it longer than one screen, because otherwise, if the list, the page size is smaller than a screen, then you can end up with flickering issues. Then you can set the initial load size hint. So this is the amount of data that should be loaded by the paging library the first time. By default, we're setting this to be 3 times of the page size. Next, we can set the prefetch distance. So what's the distance from the end of the list when the paging library should start requesting for more items? And then, whether we should enable placeholders or not. By default, this value is true. So this is what it actually means. Whenever we're getting the list of data, the paging library knows when we're triggering the request of the next list. So while that next page is being paged, the paging library just returns null for those items. So this means that right now you can add placeholder items for your list. If you don't want to work with live data and you prefer working with RxJava, you can use the Rx page list builder. So this is constructed similarly with the live page list builder by just putting the data source factory and the config. But you can either build an observable or a flowable based on a backpressure strategy. The Rx page list builder gives you a bit more flexibility, because also you can set the default fetch scheduler. You can set the fetch scheduler, and by default the architecture components would use the IO thread executor. So it will use actually the same type of executor that it's using for live data. And the notify scheduler, which by default is the same mechanism as for live data, the main thread executor. Okay, now we keep on adding a few components, but we didn't go into detail into the data in the data source. So the data source can either be the database, it can be network, or it can be the database and the network. So let's go over all of these 3 cases. So the first one, when the data source is our database. So the paging library has a close integration with Room. So this means that actually in our DAO, we can also return a data source factory. So for example, here we're saying that we want to return all the repos from the database that have a certain name. And we can let Room do all the implementation of the data source and the data source factory for us. But if the data source is the network, we have 2 different cases. One, when the data is requested based on a key. So in our remote data, we will define a remote data source that extends item keyed data source. So an example for this would be when we want to request all the commits that happen after a certain date. That date would be the key that we would work with. So more precisely, in our item keyed data source, we would define how the initial load should be triggered based on initial load parameters, and then the result should be passed to the load initial callback. And then, once the paging library has finished displaying all the data that we initially requested, it will tell us, or it will tell the data source to get the next bunch of data. So it will trigger the load after method. So more precisely here, we would get again from the load parameters the key that we're interested in. So here it would be that date that I was mentioning before. And then once the data is loaded, we will trigger the load callback, or we will put the result in the load callback. Also, if we're supporting also swipe up, we can define what should happen when we want to load before a certain item. but paging library also supports requesting data based on a page. So to do this, you would implement a page keyed data source. In our case, to request a list of repositories based on name, we would work with a GitHub API that exposes a page-based API. So we would tell what is the query, what's the page number, and what's the page size that we want to load. So this means that in the initial load, we would just request the page 1 with our query, and then afterwards we would request the following pages as we need them. And then we can also support the load before in a similar way as the item keys data source. Okay, so this was let's see like a bigger picture of what's going on under the hood with the paging library. So the first step is to build the live page list builder. When we're building the page live list builder, then it automatically triggers the create method from the data source factory, which then creates the data source. Then, based on that data source, the live page list builder will build a page list. So this means that the page list will have a reference and will work directly with that data source. And then the page list will trigger the load initial for that data source. It will get the data, and then the live data will be populated with the correct value. And then that will be emitted afterwards towards the adapter, and then the list will be displayed. But then, once we're scrolling and we're getting to the end of the list, here's what happens. Automatically, the page list is requesting the data from the data source by calling load after. And then the data source will know how to load that data and then automatically send it to the page list. Okay, let's go to a more complicated case. So what happens when we want to work with a database that is backed by network data? So in the end, what we want to do is we want to show data all coming from the database. But whenever we don't have any more data in the database, we want to trigger a request to the network to add more data in the database. So the database is in the end the source of truth of data for the UI. So this is what we need to do. So we would still work with room for returning the data source factory. But there's one new component that we need to add, and this is the boundary callback. So to the boundary callback will be the one that informs us when either there was nothing in the database or we reached the end of the list in the database. So in the boundary callback, we would define the query, we would define the GitHub API service, and the database. And then when 0 items were loaded, so let's say the first time when we're launching the application, the paging library will try to get the data from room. There's nothing in the database. So on 0 items loaded is triggered. And this is the time when we're requesting data from the backend. Similarly, once we reached the end of the data in the database, we can tell or we can define how we should request more data from our backend. Then this boundary callback needs to be set to the live page list builder so it can be used. Okay, let's see again the big picture and see what's happening. So first, live page list builder is calling build. It's calling create on the data source factory. And then the boundary callback is created when we're setting the boundary callback. Based on these two elements, the page list is being created. And now, two things are happening at the same time. So load initial is called to the data source. But also, the page list is being created. So at this time, the page list is empty. So this page, the data source is now triggering a request to the boundary callback because there was nothing in the database. So all 0 item loaded is called on the boundary callback, which in the end requests the data to the network. But then meanwhile, our live data is emitting the first page list, so the empty one, because right now we still don't have anything, our network request is on progress. With our data source, now meanwhile the network gets the data and we're saving that data in the UI. In the page list adapter, we're now displaying the page list, the empty page list. But because the data source was modified, because we've added elements in it by inserting the response from the network, then the data source needs to be invalidated. So this means that a new data source is created by triggering again the data source factory on create. But this is all done under the hood for you. So then the data source is recreated, a new page list is created, this time with data, and is then sent to the adapter. And then, once we have the data, we're displaying the data in the UI. And then, once we're scrolling the list, the first thing that the page list will do is get the data from the database. And you can also set different sizes between the list of, or the page size that you're requesting from the network and the page size that you're working in the UI. So for example, let's say you would set that you want to get 100 elements from the network, but only 50 to be displayed on the UI. So this means that initially, the paging library will request 50 items from the database. It will display those. Once you're scrolling, it will request 50 more. It will display those. But then, once we reach the end of the list, it won't have any more data. So this means that it will tell the data source to get more. It will trigger the load after method. That will call data source on item at end loaded. That will request more data from the network. And then it will save the data. So overall, this is how paging works. We're trying to simplify things, to make things easier for you in terms of both saving the data with the help of Room, but also in displaying that data to the UI with the help of the paging library. So that's it for now. We also have a workshop on architecture components, just covering the lifecycle live data, view models, and Room a bit later after lunch. So join that one if you want to learn more of how to practically work with architecture components. I think we might still have time for questions, but I prefer one-on-one questions, so I'll be here waiting for your questions. Thank you.